you could say that it's by stipulation, but this is simply the definition of what this arrow means. It means, it's called material implication. It's not the same as the word implies in English or Chinese, or follows from. That's another kind of implication. This is just a connective, and you have to decide under what circumstances phi implies psi in this sense is true. And the decision is that there's only one way to make it false. That's when the antecedent is true and the consequent is false. And you will see that this fits all the uses that we will make of that symbol very well. So in particular, as soon as phi is false, the implication is true. And as soon as psi is true, the implication is also true. So the only remaining case is when the second line here, and then it's false. So I think this will be clear when we look at how this connective also relates to the other connectives. Then you will see that this is really the natural way to define. Of course, you could have another connective with another name, which had a different truth table, but this one is by definition has precisely this table. Okay, so let's go back to what I said about valuations. So you have a set of propositional letters called a vocabulary. A valuation of these is a function v, capital V, from L to 0 and 1. So it maps every propositional letter to truth value. And then when you've done that, the truth tables enable you to give a truth value in a systematic way to every L formula. So we're going to write this more systematically without the tables, or presenting the tables in a different form. We're going to write what is called a truth definition. So you see, there is this relation on the bottom of this page, which we read, phi is true in V, but it's written with this turnstile operator, first V, turnstile, phi. But what it means is phi is true in V, or under that valuation of the atomic letters. We can also write V of phi equals 1. So we can extend V from propositional letters to every formula. This is done by means of the truth tables, but we can write it more systematically like this. So this is a truth definition. And it's also an inductive definition. You define when a formula is true with a number of clauses. One clause for the atomic formulas, the sentence letters, and then one clause for each connective. So when is a propositional letter true? Well, obviously when the valuation V assigns the number 1, or the truth value 1, to it. When is the negation true? Well, if and only if the unnegated formula is not true. When is the conjunction true? Well, if and only if both the conjuncts phi and psi are true. When is the disjunction true? If and only if at least one of the disjuncts phi and psi are true. When is an implication true? Well, here's one way to put it. It's true if either the antecedent phi is not true, or the conclusion psi is false. So that is in fact the truth table that we just wrote. It's just another way of putting it, because we're saying that either the antecedent phi is false, that's the last two rows of the table, or the consequent is true, that's the first and the third rows. So if you put those alternatives together, you get the three rows 1, 3, and 4, and that's exactly when it's true. And in the remaining row number 2, it's false. And that's what clause 5 here says, although it doesn't write the table, but the effect is the same. At this point, we can already say something about valuations and truth. We can say that the truth value of a formula depends only on the sentence letters which occur in the formula. It doesn't depend on other sentence letters. That might seem completely obvious, and yes, it should be obvious, but we can make a precise formulation of it. And this property is called locality. And you see this lemma here, the locality lemma for propositional logic, PL. It says that if we have two valuations, V and V prime, and they agree on all the propositional letters in a certain formula phi, so they give the same value to each of these letters, then phi is true in V if and only if phi is true in V prime. That's actually something you can prove by induction, and it is done, I believe, in the textbook. I will not do it here. We'll come back to proof by induction later. Okay. All right. So that was the semantics of propositional logic and the syntax. Now we can end by, we can talk about what logic really is about, namely consequence, what follows from what. And in this case, that is a relation among sentences in this propositional language. I've said sentences and I've said formulas, and that's the same thing in propositional logic. It's not the same thing in predicate logic, and there it will be important to say that consequence is the relation that holds between sentences. But for now, we don't need to make that distinction. Okay, so we have a sentence phi, and we have a set of sentences gamma. And what we want to say is that phi is a consequence of gamma. So gamma is the set of premises or assumptions, and phi is the conclusion. So how can we say that this holds? Well, as I said at the beginning, there is a clear intuitive idea about consequence in terms of preservation of truth or necessary preservation of truth. And it's written here like, as you see, whenever all the sentences in gamma are true, phi must be true. Or it is necessarily the case that when the premises are true, the conclusion is also true. The important word here is the modal word, must or necessary, because it does not say that the premises have to be true. The premises can very well be false, but the phi can follow still, because the premises can be false under some valuation or interpretation, but that doesn't matter. That has nothing to do with whether phi follows or not. What has to hold is that if the sentences are true, then the conclusion must also be true. So the trick here is to make this precise. And we can do that now that we have the notion of truth in evaluation. So I'm going to spell out this definition, and then we'll take a short break. Okay, so here is the precise version of this intuitive idea that I just expressed. Phi is a logical consequence of gamma, which we write gamma turnstile phi. If there is no interpretation that makes all the sentences in gamma true, and at the same time makes phi false. So it's not possible that the premises are true and the conclusion is false. Or, to put it more positively, if V is an interpretation which makes all the premises true, then it also makes phi true. So now we have got rid of this word must. We're still, because we're quantifying over all possible valuations. So this is for every interpretation that makes all the sentences in gamma true, that interpretation also makes phi true. So here is one thing that often is a little problem when you see this the first time. We're using the same symbol here in two ways. The symbol, the turnstile, this symbol. It can either mean true in an interpretation, or it can mean logical consequence. I'm sorry that there is this, it's used in these two ways, but that's standard, so it's something you have to get used to. But if the main thing is what is to the left. If to the left is a set of sentences, like here, then it's consequence. If to the left is an interpretation or evaluation, then it's truth. So at the bottom of this slide, you see an even more compact way of writing what I just said, and this writing the definition. And this actually uses the turnstile in two ways. So at the bottom of this slide, you see phi follows from gamma if and only if for all V, all valuations V, and then I've written V turnstile gamma. So that's a new piece of notation which is handy to use, because gamma is a set of sentences, but what I mean is that all the sentences in gamma are true in V. So it says that for all V, if all the sentences in gamma are true in V, then phi is true in V. And that's exactly what it means to have logical consequence. Okay, so now it's actually almost on the hour. So let's take 6 minutes break and start 5 past. And if you have questions or anything, please, you can write them now and we'll get back to them when we resume. Okay. So I will go and have a glass of water, and I'll be back in 5 minutes. Okay. So I have a couple of questions. I will read the questions and the answers, and you can hear them. So the first question is, would you please explain the terminology vocabulary again? Well, vocabulary, I use that word. I could also use lexicon or something like that. It's a set of, in this case, a set of propositional letters, P, Q, R, or P1, P2, etc. Later on, it will be a set of non-logical symbols. So a set of symbols. Okay. Next question, how do you pronounce the symbol for truth? Well, that's a good question. I've pronounced it turnstile, but preferably you don't pronounce it. You say, if you have V turnstile phi, you say phi is true in V. Or if you have gamma turnstile phi, you say phi follows from gamma. So that's the way to say these things. But if you, otherwise, I will just call the symbol turnstile. Next, what is the meaning of the perpendicular lines in the definition 213? Well, that actually is the definition here. The definition on this page. And as